Okay, very good afternoon to all the participants of second year ECE A and B. I welcome all of you to the next learning session, or I can say next learning journey of electromagnetic fields. So as usual, what is happening, what we are actually seeing it, or where we are traveling in. Okay, first we will see that. So we have completed comfortably the first module by last week Tuesday, and we had one class for second unit. On that particular class, we have seen what is electric field, what is electrostatics. Then we have gone for what is electric field, what is electric electric flux density. Yeah, Pavitra, you are right. What is the statement of Coulomb's law? Then point charge. We have seen what is meant by point charge, and we have seen two or more different versions of Coulomb's law statement. Okay, so what type of force of interaction will be there? Either if I say force of interaction, either it can be repulsive or it can be attractive. So depending on the what I can say, depending on the nature of the force, okay, I can say either it is a repulsive force or attractive. Okay, so that also we have covered, and today we will be focusing towards the other forms of Coulomb's law. Like Coulomb's law, we have seen what is the basic Coulomb's law. In this class, what we are going to cover is Coulomb's law, how I can put it in vector form. Okay, Coulomb's law in vector form we will first start with. Then we will enter into principle of superposition, something called principle of superposition we will enter into. So that also belongs to Coulomb's law, but what we are going to do there is we are going to generalize the terms or the expression what we seen for Coulomb's law. We are going to generalize in the sense if there are, for example, we have taken first two forces F1, F2 means our charges 1 and 2 means there I am going to consider it as ith charge and jth charge. So what will happen? Ith charge into jth charge divided by are inversely proportional to square of the distance between these two charges, that is ith charge and jth charge. Okay, that's what we are going to see. After that, we will start with Gauss law. Gauss law statement and proof. We will see to it. Then, if time is there, we will enter into the problems. Problems on Coulomb's law is very, very important. You may expect some kind of problem. Maybe it may include, like for example, if I want to find Coulomb's law for two vectors, right? So what will happen is it may include the distance formula also, what we have seen in the first module. Okay, that also will combine with this particular thing. Very interesting law. Again, Gauss law also we will cover. And I think for this particular week, I think you will be having fine like every day 9:30 to 1 it is given for placement. So obviously for this particular week, this hour only we will get it. Okay, so after this hour we will have only hour on next Monday. Okay, because all the hours is in the forenoon session as far as EMF is concerned. So our hour will get converted into placement training. So next Monday only our hour will come again. Okay, so Gauss law we will complete, and next Monday there is a chance that our CAA 1 may start. Right? Yes, Pavitra, you are right. Then CAA. So according to our plan, CAA, whatever portions we are completing, Before CAA, that will be the portions. Okay, yeah, same portion, right? So 1.5 units is the actual thing. We will see how much we are completing. Maybe in between 1.25 to 1.5 we can complete. Okay, so till that we can have, and we will be having some hour before the exam also. For example, if tomorrow is your exam, today we will get some coaching classes, right? So during that hour also we will train up, or we will go for some revisions and reviews, and then uh, you can attend the exam without any fear, without any confusion, right? So that is our plan, and I'll start sharing the screen for today. A minute. Yeah, is my screen visible for all of you?
Yes, sir.
Okay, thank you. Thank you, Kamlesh. So the title for today, as I said, it is Coulomb's law and Gauss law. Yeah, thank you, Aishwarya. Thank you, Pavitra, and everybody. So agenda for today, it looks like this. Like revision of the previous class, what we have done so far is the revision of the previous class. Then we will go for Coulomb's law. Actually, Coulomb's law we have actually we have covered Coulomb's law, we have covered, but what we have covered so far is the basics of Coulomb's law. And here we will be seeing, as I said, Coulomb's law in vector form and the principle of superposition. We will see it. Then we will go for a small topic called charge distributions. So we are having three different subtopics under this particular distribution of charges. For example, like line charge is there, then surface charge will be there, then volume charge. So we will be seeing some new terms there, like for volume charge distributions, I'm going to use volume charge density. For surface charge distributions, I'll be using surface charge density. Okay, so those new terms also we will introduce, and we will see some small definitions. Then we'll enter into Gauss law. Gauss law. Okay. Then we will start problems on Coulomb's law. See, as far as CAA test is concerned, these problems are also very important. Problems on Coulomb's law. As far as my course outcome COs are concerned, now we are in unit number 2, so CO2. It is analyze field potentials due to static charges and static electric field. Analyze field potentials due to static charges and static electric fields. That's what is the course outcome. Okay. So before going into the Coulomb's law in vector form, we have to recall the basic Coulomb's law. Can I get any one volunteer to recall Coulomb's law? Any volunteer?
So shall I say the
Yeah, Merlin.
So it states that the force between two very small objects separated by a distance which is large when compared to their size is directly proportional to the square of the distance between them. It's directly proportional to the product of charges and inversely proportional to the square of the distance between them.
Yeah, very good. So
Thank
what Merlin, yeah, what Merlin has told is the exact statement for Coulomb's law. Like Coulomb's law states that the force experienced or I can say the force exerted between two small objects whose size is very less when compared with the separation distance, okay, will be proportional directly to the product, or I can say proportional directly to the charges on each point, each objects, and proportional inversely to the square of the distance between them. Okay. So if I say like the forces will be of two types in nature. What are they? What are the two types of force of interaction? Yes, anyone? What are the two types of interactive forces between? Yeah, Renuka Devi, you are right. Can anyone tell what is it? Merlin Anita again, she is also right. Anyone from A section, you can unmute and tell. Okay. So before going into this particular thing, I want to introduce another lateral entry student who is placed in second year ECEA, Muhammad Salil. Are you there, Muhammad Salil, in the link?
Yes, sir.
Yeah, Salil. Good afternoon.
Good afternoon, sir. Good afternoon, sir.
Your name is Shahil or Salil?
Sir, Shahil.
SHAHAL.
Yes, sir.
Okay, fine. But your name has been given by your advisor as Salil. That's why I called you Salil. SHALIL. Yes. Okay. Okay, I'll change it. No issues. Muhammad Shahil. Okay. Where from you are coming, ma'am? From which polytechnic?
Sir, Pollachi. Sir, PA Polytechnic, Pollachi.
PA Polytechnic, Pollachi. You are from which department? ECE?
Sir, EC. EC.
ECE. ECE. Very good. Very good. Okay. Okay. Thank you, Muhammad Salil and Sahil. Yeah. One point to Sahil is that one unit got completed. So you go through the first unit, introduction unit only. It is simple. Get the notes from your friends. Maybe you can find some friends in any of the sections, because for both A and B, I am handling the class, and for C section, Professor Jubair Ahmed is handling the same course. So try to get the notes from either section or B section, and try to learn it. Try to write it also. Try to have one Paka notebook and try to have that particular practice. And still, if there is any doubt in our course, you can ask at any time in the classroom. Okay, in the classroom, I'm telling. Fine. So please go through it, because you have joined last week. I mean, Saturday or Sunday you have joined. After that, there was no class actually. Today is his first class. But unfortunately, from today onwards, placement also gets started, and probably next Monday, CAA1 also may get started. So you may not cope up. Okay, within 7 days, you cannot go through all the 6 papers, 6 courses. So try to collect notes or materials from students, and try to uh, put your good effort, hard work, at least for this particular week, so that you can get good notes also. Okay. If there is any problem, Shahil, you can ask. If there is any doubts in EMF, you can ask. I will make you clear. Okay. That is a
Okay, sir.
point I want to mention to Muhammad Sahil, as well as Sri Vishnu also. Sri Vishnu also joined just a week before. Sri Vishnu, are you there in the classroom?
Yes, sir.
Okay. Sri Vishnu, have you collected all the notebooks? You have got all the materials?
Yes, sir, I have.
Okay. 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 Try to collect them and start learning. Because for CAA1, you will find it different lateral entries. I think that there will be no problem for Kanishkar and Kamalesh Kumar. Again, I mean, already available level entries because they were in the classroom before that itself. Am I right? Kamalesh Kumar and Kanishkar.
Yes, sir.
One person from A and another from B. Kamalesh Kumar, he is comfortable. What about Kanishkar of B section?
Sir, yes, sir, comfortable, sir.
Comfortable. Okay, okay, fine. Thank you. It's because we have to address these level entry students. Very important because uh, before studying okay, about the college or about the faculty, directly some placement training, directly CAA one means they will find it very difficult. Okay, that's why I want to give this particular small intro, right? So Coulomb's law, we have seen it, and some question I put forward. Pavitra and Renuka Devi, they have answered it. Merlin and Anita have answered it like attractive and repulsive forces. So force or attraction from Coulomb's law will be of two types. Either it can be a attractive force or it can be a repulsive force. So you might be remembering one particular important law from Newton. It is like poles repel and unlike poles attract. Okay, with the same thing, you just replace like poles or like charges. Okay, you put it as like forces, right? So they will repel, and unlike charges, they will attract. Okay, so between two charges, we are going to find the force. Am I right? So if one of the charge is negative, automatically it will become attractive force. If any one charge, I mean, if both the charges are positive, obviously, or both the charges are negative, obviously we are going to get repulsive force. So that is a point I want to mention it here. Okay. Now we will come into the today's topic. It is Coulomb's law in vector form. Before going into this, also I'll have another question like Coulomb's law, second law. I mean, not second law. In other words, okay, by means of force of interaction, like that. Also, that is one statement I have given it in the last class. Actually, that particular Coulomb's law states that the force of interaction between two point charges is proportional directly to the product of the charges and inversely proportional to the square of the distance between them. This is another Coulomb's law. Now we will come to today's session. It is in vector form how I can define or how I can write Coulomb's law. Consider two charges Q1 and Q2 at different vectors R1 and R2 from the origin respectively. So that is two charges Q1 and Q2 at a distance of R1 from origin. Q1 is placed at a distance of R2 from the origin. Q2 is placed. You can look at the diagram also, which has been drawn at the bottom. So origin is there at a distance of R1, Q1, whose coordinates are x1, y1, z1 is placed, and from origin at a distance of R2 and another point Q2, whose coordinates are x2, y2, z2 is also placed. Now I am going to take R12 as the resultant vector, distant vector. It is the distance between two charges actually, Q1 and Q2. So this particular distant vector R12 will be given by R2 minus R1. So this is a formula that we have to memorize first, because this particular theory portion will be helpful for solving the problems. So I think you might be understanding now. From origin R1 at a distance of R1, Q1 is placed. Then from origin at a distance of R2, Q2 is placed. What is R12? It is R2 minus R1, and it is the distant vector of Q1 and Q2 from Q1 to Q2. Okay. Now what happens is the vector F, capital F, is the force between Q1 and Q2. That is what we are going to find actually, because I am having two charges, and F is nothing but the force experienced by these two charges. Maybe like force experienced on Q1 due to Q2 or otherwise on Q1 due to Q2, or I can say on Q2 due to Q1. எப்படி வேணா இருக்கலாம். But both the values will be same. The vector form of Coulomb's law is given by, see this particular formula you have to remember, the same formula what we have seen actually, but in addition we are having one unit vector. Where is that unit vector? A suffix 1 2 I have written at the last layer. A suffix 1 2 I have written at the last. Am I right? I'll take the spotlight so that you can see. Okay, so F is equal to Q1 Q2 divided by 4 pi epsilon naught R12 square. Until that only we have seen actually in the last class. Okay, now what happens is, just I am not going to have R square here. Instead I am going to have R12 square into A12. That is, so we have seen already, like F is equal to this formula we have seen already, Q1 Q2 divided by 4 pi epsilon naught. R square is the actual formula, but here I have taken R as R12, so it will become R12 square. In addition to what, I am going to have a unit vector A12 vector. So this is F vector actually. You got it? So F vector is equal to Q1 Q2 by 4 pi epsilon naught R12 square into A12 vector, where A12 is the unit vector. A12 is the unit vector. You can see here. A12 is the unit vector of R12. Okay, can you see it? And what is that A12? That also matters. A12 is nothing but, see this particular formula. A12 is equal to this formula we might be knowing. Unit vector normally will be given by what formula? R vector divided by modulus of R vector. Am I right? R vector by modulus of R vector. But here what happens? R12 vector by R12 vector modulus. So what is R12? R12 is R2 minus R1. So what happens to A12 is R2 minus R1 vector divided by modulus of R2 minus R1 vector. Have you got it? Now I am going to put this particular value in the above expression, that is in force expression. So what will happen? Okay, that is the actual net. Okay, see, Q1 has got 3 dimensions, Q2 has got 3 dimensions. Okay, so what will happen in the numerator is it will become Q1 Q2 into, right, x2 minus x1 ax vector plus y2 minus y1 ay vector plus z2 minus z1 az vector whole divided by 4 pi epsilon naught x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square whole to the power 3 by 2, whole to the power 3 by 2. Can anyone tell how you are getting this 3 by 2? How you are getting 3 by 2? Can anyone tell? In the power எப்படி 3 by 2 ஆச்சு? யாராவது சொல்ல முடியுமா? How it becomes 3 by 2? Very simple. Look at the force expression. It is F is equal to Q1 Q2 by 4 pi epsilon naught R12 square A12. A12 is nothing but R2 minus R1 vector divided by R2 minus R1 vector modulus. Right now. So கீழ வந்து பாத்தீங்கன்னா R12 ஸ்கொயர் இருக்கா? அப்போ R12 அப்படிங்கிறது ஒண்ணும் இல்ல, distance formula தான். Distance நம்ம என்ன formula பார்த்திருக்கிறோம்? If I am having 3 coordinates, 2 points, how I will write the distance? X2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. The whole root we will put it. But what happens here is R12 square is there. That means that particular square root with this particular square will get cancelled. Okay, so what is left out? X2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. But that 3 by 2 why it is coming is due to A12. So in A12 what is actually available is modulus of R2 minus R1 இருக்குது இல்லையா? Modulus அப்படினா என்னங்க? ஸ்கொயர் ரூட் தான் அங்கேயும் இருக்கும் இல்லையா? So அங்க ஒரு ஸ்கொயர் ரூட் இருக்கு அப்படின்னா அங்க to the power half கிடைக்கும். ஏற்கனவே ஹோல் ஸ்கொயர் இருக்கு, அது கூட இன்னொரு half ஆட் பண்ணா, I mean minus பண்ணா 2 ல half போச்சுன்னா what will happen? 1.5 கிடைக்கும். அந்த 1.5 ஓட improper fraction தான் 3 by 2. Okay, so that is what is the actual point I want to convey. Do you understand how this force expression came here? Any doubt in this force expression? இந்த force expression நீங்க எழுதி பார்த்தா உங்களுக்கு ஈஸியா கிடைக்கும். ஏதாவது டவுட் இருக்காப்பா யாருக்காவது? See, either you can memorize this force expression for doing problems, or if it is difficult, you understand the concept, what we have done. Remember just the basic formula for force. That is, force is equal to Q1 Q2 by 4 pi epsilon naught R12 square into A12. Just remember this particular formula and understand the concept, how to arrive at force expression. Then we can easily get it. Okay, so force is attractive if the charges are of opposite sign and is repulsive if the charges are with the same sign. Okay, so there is no reply. I hope that nobody has got doubts here, right? Good. Now I will go to the next slide. It is principle of superposition. Consider a system consisting of n point charges like q1, q2, etc. up to qn at distances r1, r2, etc. up to rn respectively. The force on nth charge is given by the vector sum of all the individual forces. This principle is called the principle of superposition. So consider a system consisting of n point charges q1, q2, etc. up to qn at distances r1, r2, etc. up to rn respectively. The force on nth charge is given by the vector sum of all the individual forces, and this principle is called the principle of superposition. The force Fi, that is here you can remember, like we are going to generalize the expression what we got it for force from Coulomb's law, that we are going to generalize. Okay, so that is what we are actually doing it. Nothing new here. That is the only thing we are doing it. Okay, so force Fi on the ith charge can be written by Coulomb's law as, in the formula already namakku theriyum, F is equal to sigma from j is equal to 1 to n qi qj divided by 4 pi epsilon naught or ji square into aij. So only one condition here is I value and j value should not be equal, then only it is valid. I not equal to j, where qi is the ith charge, qj is the charges other than qi. See, whatever charges available other than qi, those charges I'm taking it as qj, and rji is the distance between jth and ith charges. So very generalized force expression. We can get it from the principle of superposition, which is given by F is equal to sigma, summation sigma of j is equal to 1 to n qi qj divided by 4 pi epsilon naught or ji square into aij vector, where aij is the unit vector which is given by rji divided by rji modulus. And here the point is I not equal to j. That is the foremost condition that we have to remember. Okay, now that's what we have to cover about Coulomb's law. Any doubt on this Coulomb's law? Anybody has got any doubts till what we have covered? Before slide, yeah, sure. Somebody has asked the before slide. Is this slide? Yeah. See, all these things are separately important 2-mark questions. Statement of ordinary Coulomb's law, then statement of Coulomb's law in vector form, then explain about principle of superposition. Okay, all these things are separately, they are individually, they are important. Okay, shall I move on to the next topic? Coulomb's law is over. Shall we move? Yes, Renuka Devi, thank you. So we will make a move to the next head, electric field. Okay. See, electric field means here we are calling it as electric field intensity. Its notation we will be knowing it is E. So we know one relationship from the first module, units and constants we have seen. D electric flux density or displacement density is equal to epsilon into E. We know this. So from that, if I find E, capital E, which is electric field intensity or electric field, it will be given by B divided by epsilon, because D is equal to epsilon E. So obviously E is equal to D by epsilon. So it is defined as, see, there are two methods of defining electric field or electric field intensity. Number one is it can be defined as F is equal to D divided by epsilon, or it can also be defined as the electric force per unit charge. So E is equal to F divided by Q also we can have as a definition for electric field. And another formula what we have used for finding scalar potential is E is equal to minus del V. See, there should be no operator, either point operator, dot or cross product should not be available between del and V. It is gradient. So E is equal to minus del V. Okay. So these are some points about electric field. And here, according to Coulomb's law, okay, according to Coulomb's law, what is the force now? Force formula is, we know that if I am having a main charge capital Q, and if I am bringing a test charge small q, okay, and these two charges you assume that they are separated by a distance r, then from Coulomb's law how I can get our right force is F is equal to capital Q small q by 4 pi epsilon r square. So what happens to electric field E now? E, we know that it is the ratio of force per unit charge. So F by Q, small q. So what happens is small q gets cancelled in the force expression, and we will get the answer for electric field intensity E as Q divided by 4 pi epsilon r square. The unit of electric field is volt per meter. So V per, yeah. You got my point? So Q cancels here because of the definition of E. Right. Remaining is capital Q by 4 pi epsilon r square. That is the expression or alternative expression I am getting it for electric field intensity. which is expressed in terms of volt per meter. Okay. Next focus is on charge distributions. As I said, there are three types of distributions. One is line distribution, which is also called linear charge distribution. By using this linear charge density, we are going to distribute it. Then I am going to have surface charge distribution. Then I am going to have finally volume charge distributions. Very simple formula, just you remember. So if I go to linear charge density, how it can be defined? It is defined as the total charge distributed over a line or curve. Very simple. So linear charge density is expressed as rho suffix L. Okay, rho suffix L is the notation used for, see, this is the notation used for linear surface, charge density. Rho L is equal to limit del L tends to 0, del Q by del L. Charge per unit length, that's all. See, at the bottom portion you can see this gives the total charge per unit length. Total charge per unit length, and it is given by rho L equal to Q by L. This is the point which we have to remember here for linear charge density. So it is defined as the total charge distributed over a line or curve. So rho L is equal to limit del L tends to 0, del Q by del L. This gives total charge per unit length. It is given by rho L is equal to Q by L. See, இதுக்கு மேல del Q by del L னு போட்டோம் இல்லையா, அதுக்கு பதிலா Q by L. Q ஓட யூனிட் என்ன, கூலும்ப், length ஓட யூனிட் மீட்டர். So it is expressed in terms of கூலும்ப் per meter. இதே மாதிரி தான் ரிமைனிங்கும் வரும், நீங்க பாத்தீங்கன்னா தெரிஞ்சுக்கலாம். Next I will go for surface charge density. There you can see. So surface charge density means it is defined as the total charge distributed over a surface. So there what we have written, distributed over a line or curve we have taken, and here it becomes surface. So there we have written the notation as rho L. Here it will become rho S. You got it? This becomes rho S. So rho S is equal to limit del S tends to 0, del Q by del S. And also this gives the total charge per unit area, and the formula is rho S is equal to either Q by S or Q by A. Q has got the unit of Coulomb, and S or A, surface area or area, will have the unit meter square, so it will become Coulomb per meter square. This is what is surface charge density. Can anyone guess what may be volume charge density? From this particular slide, can anyone guess what may be volume charge density is? சொல்ல முடியுமா யாராவது? Guess பண்ணுங்க பார்க்கலாம். இப்ப நம்ம linear charge density we have seen, then we have seen surface charge density. Now can anyone guess what can be volume charge density is? Yeah, Sibikanna, you are right, it is Q by V. What is the notation used for volume charge density? What will be the notation used for volume charge density? Yes, anybody? Yeah, Pavitra, you are right, it is rho V. Rho suffix V is the notation used for representing volume charge density. Shall we move on to that particular slide? Yeah, I have moved it. You can see it is defined as the total charge distributed over a volume. So rho V is equal to limit del V tends to 0, del Q by del V, and this gives the total charge per unit area. It is not unit area, this particular thing you have to change it. This is actually unit volume. I am changing it here, right? Please change it. So it should be unit volume. Okay, and is given by rho v is equal to Q by B. So Coulomb per meter cube. You got all these things. What is linear charge density? What is surface charge? And what is volume charge? Have you got it? Any doubt in these three definitions? And any doubt in the electric field intensity definition? Doubt Raja. Okay, thank you, Anjali, Pavitra, and doubt. Now we will move on to the next important law, which is Gauss law. Okay. So Gauss law statement and proof. With that, we will try to stop our class today. Okay. So Gauss law, Michael Faraday's experiments lead to a statement as given below, which we call it as Gauss law. So who's the scientist is? This is Michael Faraday, Alexander Michael Faraday, right? So he has done lot of experiments, okay, and he has given some statements, okay, from which this Gauss law has been formulated. What is the statement of Gauss law? The grammatical statement of Gauss law is like this. Gauss law states that the electric flux passing through any closed surface, the electric flux passing through any closed surface is equal to the total charge enclosed by the surface. The electric flux passing through any closed surface is equal to the total charge enclosed by the surface. Mathematical definition is, so what is this left hand side symbol is called? You have already named it. Can anyone tell it again? What is this symbol called? Yeah, Merlin, you are right. It is psi.
Pi, sir.
Yeah, psi. Very good, Anjali, Pavitra, and all. It is psi. Psi is nothing but the notation used for electric flux. So that is equal to the total charge Q. So psi is equal to Q is the statement of Gauss law. But remember that this psi is the electric flux, because if I go to magnetostatics, again that is magnetic flux, that particular term will also come and confuse us. Okay, for that notation is different, and here it is psi. Okay, right. Now we will move on to something called Gaussian surface. See, the diagram which I have drawn here at the left hand top is, we call it as the Gaussian surface. So there I am choosing a shaded portion, a small portion at point P in the region whose surface area is ds, and at that particular point charge prevailing is capital Q. Okay, and ds is the surface, capital ds is the electric flux density D will have ds, and its normal is also there with the name ds normal, and this ds and ds normal will be separated by a small angle called theta. So consider a small element of area ds in a plane surface having a charge q, and capital P be a point in the element. At every point on the surface, the electric flux density D will have value ds. Let ds make an angle theta with small ds. The flux crossing ds is the product of the normal component of capital ds and small ds. So what has been given here is d phi. The flux crossing means d phi. D phi is equal to capital ds normal small ds. So always normal means it becomes cross product. Am I right? So what can be written is ds cos theta. We can write it. Okay. So what happens to d phi? So actually we know a vector dot b vector is a vector modulus b vector modulus into cos theta. So here if I am having cos theta value, it becomes a dot product. So what will happen? D phi is equal to capital ds dot small ds. So d phi is equal to ds normal ds. Normal means obviously the angle is cos theta, because then only the adjacent side will come into picture. Okay, so it becomes ds cos theta ds, small ds. So if cos theta is there, obviously it becomes a dot product. So d phi is equal to capital ds dot small ds. Okay, dot product. Okay, now the total flux passing through the closed surface. So d phi we got it actually, from which we have to get phi. So what can be done? We have to go for integration. Am I right? Double integration or mere integration, because then only integration and differentiation will get cancelled. So obviously phi is equal to integration of d phi, which is equal to surface integration of capital ds dot small ds, because in the previous slide only we have derived d phi s ds dot ds and the value everything up to, and we know that ds dot ds integration, if I do it, I will get charge. So that is the actual Gauss law. In terms of volume charge density, if I want to express this Gauss law, it will become phi is equal to, see in the top portion what we have written is in terms of surface, and now it is in terms of volume. So phi is equal to volume triple integration of rho v dv. So rho v dv is nothing but q. This is again charge. Okay. Now I will come to the proof. Consider a charge q at origin, of a spherical coordinate system. See, for my convenience of proving the Gauss law, I am taking as a sphere actually. Okay, spherical coordinate system whose coordinates we know it is r, theta, and phi as shown. Radius of the sphere you assume it as r. The electric field intensity due to capital Q charges, this particular thing we know already, right? E is equal to Q by 4 pi epsilon r square. That is why we have seen electric field before some slides. So spherical surface means Q is equal to, E is equal to Q by 4 pi epsilon r square. So electric flux density, what it will happen? Electric flux density or displacement density is capital D, which is given by epsilon into E. So E value we know, epsilon cancels out, remaining is D is equal to Q by 4 pi epsilon. Sorry, epsilon gets cancelled. So Q by 4 pi r square. That is what is the value. Okay. See, after I am telling it here, then we will come to the board actually. From spherical coordinate system, we know that we have got three different formulas for ds, differential surface, because in the starting itself we have seen what is differential length, what is differential volume, what is differential surface. For differential surface we have got three different formulas. Out of those three formulas I am taking one formula to my convenience. So ds is equal to, one formula is r d theta into r sin theta d phi. So r into r is r square sin theta d phi. Okay, this is the value of ds. Now from the basics we know that electric flux psi is equal to integration d psi. See, here I have written as phi actually. This is not phi, this should be psi. Phi is the notation used for magnetic flux, not for electric flux. Integration d psi is equal to surface integration of d ds, that we know already. So what is the value of ds now for spherical coordinate system? Ds is r square sin theta d phi. What about d? D now only we have written from the previous slide. It is q by 4 pi r square. So I am going to substitute those values here. So it is d into ds, d dot ds. So d value is q by 4 pi r square. See, I take a small thing. See, this particular term is nothing but my d value. D value we have already written it. Okay, it is nothing but q by 4 pi r square for a system. And ds we have written it is a differential surface. So for a spherical coordinate system, we have got three different formulas. Out of three formulas, I am picking one formula and I am manipulating it. It becomes r square sin theta d phi. Here, I am taking q by 4 pi as common outside before the integration. And I am picking the integration limit as theta to be 0 to pi and phi is from 0 to 2 pi. Because for phi, as I said already, if you have gone through the mobile app which you have downloaded, you can understand phi value if I am varying to 360 degrees, because 2 pi means it is 360 degrees. If I do that, I can get some plane surface. Okay, theta value is half of it, so it is 0 to 180 degree. So integration range is theta is from 0 to pi and phi is from 0 to pi of r square cancels, remaining is sine theta d theta d phi. So the point is we have to integrate sine theta with respect to theta and with respect to phi between the limits theta from 0 to pi and phi from 0 to 2 pi, and we have to derive the answer. Okay, if I do it, what happens to the answer is in the next slide. See, if I derive it, if I apply the value will be equal to derivation value phi is equal to q. I will get it. The electric flux crossing the surface is equal to the charge enclosed by the surface. I can get this particular answer. So this is what we have to prove actually. And also this particular thing is very important. The Gauss law can also be stated in point form as, okay, this particular law is important for 2 marks. Gauss law can be stated in point form as del dot D is equal to rho V. Del dot D means what? Divergence. Divergence of electric flux density. Divergence of electric flux density is equal to rho V. Rho V is nothing but volume charge density. Okay, this is what is the point form of electric Gauss law. Okay, so with this we are actually closing our proof. Any doubt in the proof anybody has got? Proof la irukka the doubt irukka? Before slide I went through Pavitra எந்த slide வேணும்னா உனக்கு? Which slide you want? The derivation slide or see I moved to the front. Proof slide. Which slide in proof we want? The last page, right? This one. Four. Okay. See here actually this q by 4 pi I am taking it out as common. This r square with this r square cancels. Okay, remaining thing is I have written this one I have taken out. This is surface integration, so 2 integrations will come. Sine theta d theta d phi is there. Integration limit of theta is from 0 to pi, of phi it is from 0 to 2 pi. First I have to integrate with respect to theta. So if I integrate sine theta with respect to d theta, what will happen? Integration of sine is minus cos between the limits 0 to pi. Okay, see, just you write now. Next class, while we are starting again, we will see this particular proof and then we will go to the problems. Okay, no worries. In between that, you try to understand what has been written here. Then next, the last line, if I apply the limit for cos, what will happen? So upper limit is pi and lower limit is actually 0. So upper limit minus lower limit is the actual thing. You may write. So how it will become is minus cos phi minus of minus cos 0 it will become. I'll make a move. Yeah. So minus cos pi. Cos pi is already minus 1. So minus of minus 1 is 1 plus cos 0 is 1. 1 plus 1, 2. So it will become 2 actually. 2q by 4 pi. That's why that particular 2 and the denominator 4 gets cancelled. Remaining is 2 pi. Q by 2 pi. Integration of d phi with the integration limit 0 to 2 pi. If I do that, it will become 2 pi. So 2 pi cancels. Remaining is just q. That is phi electric flux phi is equal to q. Psi is equal to q. We can get it. That is why the statement is written as the electric flux crossing the surface is equal to the charge enclosed by the surface. See, you please go through the mobile app also so that you can get the Gaussian surface. You can get some applications, infinite charge sheet, infinite current flowing, all these things, applications that will be described in the mobile app very clearly. That also you can go through. Okay, that covers Gauss law and its applications. Okay, so time is now 4:15. Shall we wind off the session? Okay. Any doubts? Anybody has got any doubts? Okay. So we will close our session now. We will meet in the next session with Coulomb's law problems. Right. Thank you so much.